All right, welcome to my first recording of the Delta Platoon. No. Okay, so right, so we are focused on looking at how to solve the deaf grandma program problem, right? So what I did is I created a JavaScript file, which again, as we remember, touch deafgrandma.js. I know I made a folder for myself called Delta, so I have that in there, and then I opened that in Sublime, which is where we are now, right, with our Sublime file in Sublime text, or JavaScript file in Sublime text, okay? So one thing that you probably notice that is a little different here is that there's counting here, but we'll explain that in a minute, right? So we have our function that we want to build our program with, okay? And we know that we need to use prompt. So the first thing that we can do is utilize the prompt library that many of you have looked at yesterday, right? So the requirement for doing that is in step 1 is installing prompt. Yes, question, installing prompt through Node's package manager, which is what NPM stands for. Question.
That is not particular to this one program. I think the question yesterday, whether installing it can be accessed in any directory or just
good question. So we'll talk about scope. We'll talk about scope at another point. If we're installing prompt in this folder, then we're basically downloading NPM to be utilized within the scope of this folder repository. If we install it in another folder, it might or might not be accessible, but the tag you would use if you wanted to have it accessible at all times, no matter what, even if I forgot to install it in another repository, would be, oops. Oh no.
I mean, that's what's going to be useful, right? So if we learn sort of this, learn how to use a function like this, we can be able to access it, right?
You could, but in real, so the command line is not necessarily an interface that you're going to build programs upon very often. It's useful for you right now because you're wanting to interface with the program that you're building. Soon you'll be able to build stuff that people will be able to interface with from the browser and then from web applications, right? So being able to prompt within the command line is not going to be a priority for you in the very near future. So right now, it's useful to know how to download a package. It's useful to know how to get around the problem of dealing with prompt at a command line level. Maybe one day you do build programs that allow you to build command line interface type programs, but it's not going to be a priority for you as a web developer. Does that make sense to everybody? So you already so knowing how to use prompt will be good, but not necessarily knowing how to use this particular library. But knowing how to use libraries in general will be valuable for you. Make sense? So npm install prompt -G is an option which would make it global installation. For now, you really don't want to or need to do that, but that is the way to do it. Not really. It's just like putting extra, it's just giving, it's like saying everybody can come and take the cookies. Like everybody in the world can come take the cookies from our room, right? It's like, do we really want everybody to take the cookies? Do we need that much traffic in our lives right now? Maybe not, but it's not gonna hurt anybody if we give all the cookies away. So it makes sense. It's not installed to a different location. It just gives the computer access, it gives your programs access to that no matter where they're at. They'll know, okay, it's in a global folder versus maybe being able to access it in the local repository. It might or might not end up in a different folder. But point being, that's what's going on here. Okay, line 1. We're installing the library, and then we're asking for it here on line 2. We're saying, okay, we're naming prompt variable to require that prompt library so that we can bring it in and utilize it in our work. Okay. Okay, the next step we can do is just have a first step of saying I think at this point we had something say, hey kid, right? That was the first thing in the, this was actually in our challenge saying, hey kid, and then waiting for a response from the kid or the person who is like running this program, right? Okay. The next step for utilizing the prompt library is using the methods that are available in that library. So this is starting the ability to use prompt. So prompt.start. Okay. The next step we would use is the function called get. So prompt.get is actually making the request of the user or getting the output from the user, right, on the command line. So ask grandma would be put to the screen, and then we're getting the result, or like we're dealing with what happens if there is an error. In most cases, in this case, right, we're not going to get an error, but in case we know how to be able to handle it if we do get an error. Okay, now the counter equaling 0 here at the top, this is what's called setting a default argument in JavaScript. So we're saying like right now the count is 0, like nobody has asked for anything that we need to count up, so just set it to 0, right? But eventually we're going to be utilizing it here on line 8, saying if the counter that we've defined here as a default to 0 gets to be, or while it's less than 3, right? If the counter is less than 3, then take the result of the prompt and utilize that as the input that the user is giving us. Okay? And then,
that's going from the function here.
so this get function is a part of the prompt library. Yeah, and it's a way to ask for a command line, line of whatever that somebody wants to write to us, right? It's being able to get that out, the standard in, basically, okay? So we're saying, okay, now we're naming that as input, and then we're evaluating it here. So if the input is...
The input is result.aspect, so it's what, here's the response.
Yeah, so this is the response. For, like, whatever text was written in the command line, this is going to be that response, right? In this case, it's being called result. Like the result of getting something is the input, okay? We're naming it input. So if input is an empty string, the output we're going to give is what? Okay. Else if the input is equal to, and the triple equal, input to uppercase. So if we're saying the input is in capital letters, right? It's equalized to that input at an uppercase. We're saying no, not since 1946. Okay. Else if above that, so this is what's called a regular expression. You'll learn about that later, but the point is that we're evaluating else if the input is tested against this regular expression. We'll learn about regular expressions. It basically means pattern matching. So if anything in the input is also matched to anything in the letters A through Z at a lowercase. So a lot of us we're trying to figure out like mixed case, like if there's certain letters that are uppercase and lowercase at the same time. So this is saying if there's anything in this string that has a lowercase letter and response and the result is true, right? Then we're telling them to speak up.
That's the module.
No, test is a function that's part of JavaScript that you can utilize. It allows you to utilize like a pattern, a regular expression pattern.
So that could be all uppercase too.
Mm-hmm.
So now we don't have to do this big.
Two upcase or two.
Yeah.
You can still utilize this, but this is this solution.
This is more condensed.
Well, no, this solution is specifically looking for lowercase letters in a string that could have uppercase letters or other characters that might not be lower or uppercase. So instead of me having to extrapolate the uppercase letters only and the lowercase letters only, because to uppercase to lowercase are only going to evaluate like those extremes of all uppercase, all lowercase. But this is going to pattern match any lowercase letters that may be mixed into that string. So that's what that's solving, okay? So we're saying the output is speak up kid, right?
Can you do the same thing for numbers? Like,
Yes, yeah, so you can, for any character, you can utilize pattern matching. But we'll get into pattern matching and regex next week, I believe. For now, just know that that's like the way that we've solved it, right? So we're utilizing a lot of if else, right? So if we go into here and we say, I think this could have, like, a better way that we could have utilized some pseudocoding, which we'll talk a little bit more about in a little bit here, is making sure that we know these are all the steps that I want to make sure are happening, right? So this else if else, it looks really complicated right now because we're putting all the else if else based on what we already know the program should be doing. It's a little difficult for you to see where we're placing things based on what should be evaluated at what point, okay? But the last part of doing this, which is where the counter comes in, we're utilizing this evaluation at each instance that we're getting input from the user, okay? And then further down here, if somebody is saying goodbye, specifically in uppercase with the exclamation mark, right? If the counter is 1, we're saying leaving so soon, and then we're increasing that counter. Okay. At what point does the counter get increased?
I thought it was just going to be like counter 1.
Right. It seems like we're missing a counter maybe. Also, if we'll run this program real quick and then we'll debug it. But
if the counter starts at 0.
yeah, if the counter starts at 0, then when you get to this point where input equals goodbye, we would count up to 1. And then if the counter's 1, so we'd probably count here. Counter plus, right? If the input equals goodbye, we'd plus up. If the counter is 1, the output would be leaving so soon, and then we would plus up again, right? We would run this loop again because we would be waiting for the user's input. If they continued to say goodbye, the counter at that point would be 2 because it gets incremented here again, and then it would go down to here, and then we'd say later skater, and then the counter would end up at 3. It would run this again. It would get to 3 here, and then it would go down here, and then it would exit the program. Okay, so we're utilizing a counter mechanism to make sure that we're taking advantage of the fact that a user can say, we're asking the user to say something twice, right? So the first time they say it, we count that. Then we run that again. The second time they say it, we count that. And we know that we've gotten up to the times that they need to say it. And then that is going to allow us to break out of this loop and close the program. Okay?
So basically, it seems like everything that, other than the prompts, functionality, got from the prompts, is all basic stuff we've covered.
Mm-hmm. Yeah. So, do y'all have any questions about this, or does this make you even more confused or feel a little more clarity? How are y'all feeling? What happened? What is going on line 28?
So it's just this function call inside of that same function. So it's just continuously calling. And this is where it looks like it's an if. So you're doing like a loop. If there's a counter. This is where I got messed up. I was trying to use a while outside of that function, but it was calling the prompt, and it was just like calling prompt over and over and over and over again. Even though the prompt call was inside of the function, the while loop was calling the function outside. But I think everything maybe has to be inside of that prompt call to keep it from doing something like that. And this one, like, it's just recursive, and there's like a loop with an if, and it's all inside of that prompt.get function, or the function inside of that method or whatever it is, or the get method. And I guess that's what was making it like continuously call prompt, like look for response, right?
Right. Anytime we're utilizing like if, while, right, for all the loops, we just want to make sure that that we're either, if we're making iterations that need to change in order to continue the evaluation, we need to have some kind of like increase or decrease in our iteration, or some kind of way that things are being counted. That oftentimes happens with for loops, right? Because we already have the incrementer at the top of a for loop, whereas if-else statements, they're just going to be checking whether a condition is true. And if you're not changing that condition, right? If you're not changing that, it's going to always be true. And so that's what the downside is to utilizing while loops that don't have incrementers or counters that.
I was using like the same thing, the counter and the while. Since I guess it was outside of that get method.
Right.
It was just calling the prompt over and over. It wasn't.
It might, yeah. The evaluation might not have been coming out outside of that scope of the while. So it was continuously evaluating to true. It was just like, if it's true forever, I'm just gonna keep going.
So if you scroll down a little bit to where you sort of brought in the statement at the bottom. Yeah. So the last one, 27. So if the counter is less than 3, what happens if like you kept saying like hi, like all lowercase? Doesn't that make?
So if you kept saying hi, lowercase, right?
Yeah.
And we're saying the counter here is being re-entered into, and we're running this function here, right? So if we said hi in lowercase, it would run back up here, right? It would run this function. So it would say the counter is 0, the grandma's listening, right? It would run through this whole process again. It would say the counter still hasn't changed. The input,
Speak up.
she would end up here, right?
Yeah.
And saying speak up, kid. And then at that point, the output would be speak up, kid, right? And then it would run to none of these other pieces would run true. It would go through this else if, okay? And then it would run back down here. It would evaluate the counter, and then it would run the program again.
So what is the counter at after one duration?
The counter would be 0, because the only time the counter gets changed is when goodbye happens.
Okay.
Does that make sense? So the only time we're dealing with counter here, so if we highlight counter, okay, counter is being evaluated here for its value. Here, counter is being incremented up. So only within this else if statement is counter being incremented up, and then this if here, right? So like within these lines, 14 to 22, that's the only time the counter changes. And that's because the counter's only purpose is to count whether or not somebody is trying to leave. So if I said goodbye once, I said goodbye twice, so the program will close. Make sense?
When is it actually out, like printing out?
So output.
Setting the variable.
We're changing the variable for the output here. Good question. So the output, so prompt.start and var output. That is actually a good question.
Just prior to the if statement or something like that, or
I think it's returning. We're returning output. Yeah. I think that's probably the only thing that needs to get changed here. Let's see. console log. Yeah. So, but this is the process that we took for making this program happen. Cool.
So I understand the benefit of console log algorithm. Why would you just have console log going on since 1946 and for all the other?
Instead of having an output equals, why would you just do console.log? No, not since like console.log later, later.
We could definitely have that.
Probably just that's a little less typing. You just do output equals console.log. Or it's just output equals whatever. Maybe just a few less detail.
Yeah, because it's really just a value, like the prompt happens once, right? The prompt happens within this function. The prompt happens once, and we're getting one response from grandma, right? So once we get one response from grandma, we only need to console log that response once. And then we need to run the program again if the counter is less than 3. Yeah, otherwise, if you put a console log in each of these, it's only going to run that line of code when this is else if or else. When any of those conditions ring true, that's the only time it's going to enter into any of these blocks. So that's also correct, right? Like you can put console log in any of these, and it's only going to run that console log when that condition is met. So instead of saving output at any point, we could also just console log it. Yeah, either way. Okay. Awesome questions, everyone. Thank you for that. I'm going to close this because it makes me hurt inside looking at it. So I know a few of you had had some different ways that you did it. Does anybody want to talk about, like, I really liked Deja's solution for this. Do you want to talk about how you found that, or like what you did? Because I thought it was really cool.
Oh, instead of
so, and read line it just to tell us all what it is, because I.
okay, you just use the whole line.
Yeah.
So I looked at the box for JavaScript and development. Use that. Like the structure is the same.
Cool. Yeah, so again, that's just to illustrate the fact that like we gave y'all like 2 tips to like trying to figure this out. It doesn't mean that there's not another solution to figuring it out. And we like want you to be able to say like, okay, what's another way I can figure this out? Like you don't have to necessarily solve the problem in the exact same way. As long as the program runs, it does the work, right? And then you're able to like learn from that process. That's the point of these challenges. I'm going to do a pause on the recording.